This is Unit 2, Lesson 3, the notes for domain and range, intercepts, increasing, decreasing, and behavior. Pretty much just we're going to take a look at all the characteristics of graphs. This is something that you will continue to see throughout the year, not just in this unit, but as we begin to explore new functions, we'll need to be able to identify these key characteristics. So we're going to start off by taking a look at domain and range, and I'm going to kind of go over each little concept and then take a look at the example at the bottom of the page. To highlight, I'm looking at this first graph, which is our quadratic, y equals x squared. And then we'll go take a look at a couple other examples and put it all together. So the first thing we'll talk about is our domain and range. Now, domain and range should be reviewed from previous math courses. What might be new is the notation that we're going to use, and we're just going to use our set builder notation to identify domain and range. But keep in mind, domain is all the x values, okay? It's all the possible x values for the relation or the function. And something we'll want to keep in mind as writing this is that our quadratics, our absolute values, even our square roots have arrows on them, meaning they're going on forever, ever both in our x's and our y's. The range are all of your y values. All right, so we just want to identify the x's and the y's for each graph. So if we take a look down here at y equals x squared, our quadratic, we can see it's already drawn for us. We want to think about first the x values. What x values are represented in this graph? So let's take a look and let's find our vertex point, because that's going to help us labeling some of these other concepts as well. So we know since it's our parent function that vertex is here at 0, 0. It hasn't shifted left or right, or up or down. Okay, so thinking about from there, x is this axis right here. It's running sideways. So what possible x values does this graph cover? Now, we don't want to actually list out like 0, 1, 2, blah, 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 because A, that's going to take forever. B, we're never going to finish because keep in mind our graph is going on forever and ever. Plus, we also have all the decimals in between and all that good stuff. Now, looking at this graph, let me outline it in red. We see, you notice there's arrows on it, implying that it's continuing. What you need to keep in mind, though, is as I'm looking at this, to me it looks like it's going up and down, which it is. But as this graph is going up, it's also getting wider. So for each point, for every point that has a bigger y value, it also has a bigger x value. So this graph is also continuing on this direction to the right. And it's doing the same thing to the left. However, it's not as visually clear to us because it is getting higher faster. But do keep in mind that it's also moving all the way to the right and to the left. So when we look at it, our domain is really all real numbers. This graph is continuing on in both directions to the left and to the right. So for our domain, we can say it's all real numbers. So as we write our set notation, we say x is just an element of the reals, and that's all we need to put here. We don't have any restrictions. We don't have to write x is less than or greater than because there are no restrictions here. Every single possible real number is represented in our domain. And what you're going to notice is really any function that has two arrows to it is going to have that domain, okay? Now keyword is any function. So any function with two arrows will have a domain of all real numbers. Our range is going to be a little bit different. Okay, we're talking about y values, and there are two arrows, but they're both pointing in the same direction. So as x is getting bigger, so is y. It's going up and up and up. As x is getting smaller, so is y. It's going up. So y is not our domain. Our range is not going to be all real numbers here. Okay. Sorry, all right, I have a restriction, meaning a point where the graph has something we need to consider, which is right here, a vertex. If you notice, your graph is not going below that point. There is no y value below my x-axis, okay? There's no y value below the y value in my intercept. So really, y is going to be anything that's greater than or equal to 0. So we can go ahead and write that in our set builder notation. Make sure you use y this time because it's the range, is an element of the reals such that y is greater than or equal to 0. Okay, y is greater than or equal to 0. The next thing we'll talk about are intercepts, which are just what they sound like, intercepts, where something is crossing another part of the graph. So an x-intercept is where it's touching the x-axis. A y-intercept is where it's touching the y-axis. Right, we're also going to talk about the concept of zero. And a zero is the x value where a function touches the x-axis. So pretty much zero and x-intercept are the same things. However, the way we write our answers is different. A zero is x equals whatever that number is. So if it's crossing at 5, it's x equals 5. And please notice that is a number sign, not a hashtag. Thank you. For an x-intercept, you write it as a point. So that's the main difference between the two. All right, so when it's an x-intercept, it's going to be whatever that number is, comma 0. Because do keep in mind, any number on the x-axis has a y value of 0 because it has not moved up or down at all. And a y-intercept is where it's crossing y, so it's 0 and wherever that number is. Okay, because all y-intercepts have a x value of 0 because they have not shifted left or right. All right, so zeros. Let's take a look. So my graph, the only zero is right here at 0. All right, and as we shift it around more, you'll see different ones. It'll talk about how we can find them. But for right now, my 0 is x equals 0. My x-intercept is 0, 0. And my y-intercept is 0, 0. So they all happen to be the same in this case. But as we shift around, we can just look and identify our different ones. If you're not sure, you can always plug and solve. So for example, for y equals x squared, if I wasn't sure what it is, to find the x-intercept, keep in mind that the y values of all x-intercepts are 0. So I could plug a 0 in for y and solve. So here I could just take the square root of each side and I get x is equal to 0. So that tells me where it's crossing x. And then likewise, to find the y-intercept, I could plug 0 in for x and solve for y. So I get y equals 0. So if you can't see on the graph or it's looking like it's hitting at a decimal or fraction, plug 0 in for the other value, other variable, and solve to get the exact intercepts. All right, the next two concepts are probably going to be new for you. We've got talking about increasing, decreasing, and constant, and then end behavior. All right, so first, increasing, decreasing, constant. What we're doing is we're finding out for which chunks of the graph is the graph increasing, for which chunks is it decreasing, and for which chunks is it constant. All right, key phrase here, we're always working from left to right. Just like you, when you're reading a book, your eyes are scanning left to right. All right, so increasing and decreasing is actually referring to the x values. What it's saying is for which x values of the graph, so as the graph is moving from left to right, that's key x values. So for which x values are the y's getting bigger, meaning for which x values are the y's on an increasing trend? For which x values are they decreasing? And for which x values are they staying constant? So let's take a look at this picture down here, this graph. I'm going to erase what I have on here so I can redraw some things. Maybe it's moving it very slowly. Okay, I'm going to keep that 0, 0 label, that vertex. So what we're going to do, guys, is you're going to trace it from left to right. So looking at it, the left part of the graph is over here, right? Left, right. So first take a look at this first part. If I'm moving left to right, which way am I also going? Down or up? I'm going down. My graph is on a decreasing section there. Okay, now when I get to my vertex, that's what's called a turning point because I'm changing directions. Notice it turns around and now I start to go up. So we want to identify between which x values are the two happening. Okay, let's first start with our decreasing and just make sure you're reading and writing on the right line. Decreasing between which x values? Okay, well this x value is 0 here, right at the turning point. What is my x value over here? Because remember, I know this graph is looking up here, but it's coming from the left. We're thinking x values now. Don't get your x's and y's confused. Because as this graph is continuing, it's also x values are getting smaller. So what are the x values on this side of the graph? How can we identify what's happening? This is your negative infinity. because as you're, notice -1, -2, -3, -4, etc. As my axis is extending to the left, my my x values are getting smaller. So it's decreasing from -infinity to 0, and we just write that as an inequality. Okay, it's decreasing from -infinity to 0. At 0 right here, it turns around and goes the other direction. So that means it's increasing from 0 up to positive infinity. Okay, it's increasing from 0 to positive infinity. So the graph is going up between the x values of 0 and positive infinity. So as we're doing this, you can always start by labeling your x-axes if you want to, if that helps you. We could also label our y-axes with the same concept. Going down, these are my small y values, so those are my negatives. These are my bigs, those are my positives. That's actually going to help us in our end behavior. Now constant. Constant is where you have a plateau in the graph, which we don't have here. We don't have any point for which the x's are leveled out. So we can just write NA, or we can put a dash here. NA stands for not applicable. There is no answer for that. All right, end behavior. Okay, so increasing, decreasing, x values. End behavior are your y values. So end behavior is just saying, hey, really, it's as basic as which way are the arrows pointing. Okay, so we're saying, so for the right end behavior, meaning as that graph is continuing on and on and on and on, which direction is that arrow heading? Are the y values getting bigger or are they getting smaller? And then for our left end behavior, we're saying the same thing. Okay, so looking down here, look at my notation. I've got as x is approaching infinity. Which side of the graph is that? That's my right side because we're saying as x is getting bigger, what is y doing? Well, as x is getting bigger, so is my y. It's going up. The arrow's pointing up towards positive infinity. So I can just put a positive infinity here. My next chunk says x is approaching negative infinity. Negative infinity are your small x's. That's the left side of the graph. So we want to see what our left arrow is doing. Because as my x's are getting smaller, notice my y's are getting bigger also. They're going towards positive infinity. So for end behavior, you really can just take a look at your arrows and see which trend, which direction they're heading in. All right, so as you start going and we're piecing this all together, there's just a few suggestions on steps on how to do this. First, label any endpoints, turning points, and arrows. Okay, so turning points, really your vertex. Endpoints are going to be dealing with your square root, which we'll talk about. And then you're labeling, and then labeling your infinities. That's going to help you, okay? Remember, domains going from your smallest x to the largest x, range as smallest y to largest y. Determine your x intervals for increasing, decreasing, and constant. Break the graph into zones. So if you notice when I was doing this, I drew a dashed line. Ugh, sorry, everything moved around, sorry. But there was a dashed line drawn here that went right through my turning point, because that kind of helped me chunk it up, and I drew my arrows indicating which direction I was heading. All right, then end behavior, just take a look at your arrows. Okay, so let's do two examples together. Now this graph's a little different. It's a function, but it's not one of our new function rules. There's no equation that we could use to plug in and find every point on here. So we have a couple things going on. We do have a constant in this graph. And if you notice that your constant is right here. Okay, so we'll come back to that. You also may notice we only have one arrow. Okay, so let's go ahead and let's label our infinities. Positive infinity. It's a negative down here, a positive over here, I'm sorry, negative over there, and a positive up here. Let's label any endpoints, okay? So this endpoint is happening at -3, 1. Now we do have other points here, so let's label them for now because I notice things are turning and changing shape and direction. So it can't hurt to have coordinates labeled. We may or may not use them. So that's -1, -1, and this is 2, -1. Okay, so let's talk about domain. Let's talk about our x values. There aren't two arrows, so it's not going on forever and ever and ever in both directions. I do notice, though, that I have an arrow on the right side, so my graph is continuing both up and to the right. Okay, so I can use that to help me. But what is the smallest x value we see here? It's right here at -3. But everything else is included. Okay, so for my domain, I can say x is an element of the reals such that x is greater than or equal to -3. And notice I'm using an equal to because it is closed in. I do have to keep in mind that I could have an open circle drawn there, so I wouldn't have that equal to symbol underneath. All right, let's talk about range. Range are your y values. Once again, I have one arrow, so it is continuing up, but it doesn't continue down. This is the lowest point right here at -1. It does not go below there. So my range is y is the element of the reals such that y is greater than or equal to -1. Zeros. Where is it crossing? Okay, I see it crossing right here at -2 and at 4. That's where it's crossing the x-axis. Remember, zeros are x's. So I can write x equals -2 and x equals 4. For my intercepts, I just change those into points. Right, and my y-intercept, it's crossing right here at -1. So I need to write that as a point. Y-intercept will always be as a point. Okay, new stuff. Increasing, decreasing constants. So my graph, what is it doing? Okay, let's take a look one section at a time. So if I'm tracing it like this, which way am I going? I'm going down. Here I have a constant, and then here I'm going up. Yes, it's going at different rates throughout, but it's still in an upward trend. So decreasing. It's decreasing between -3 and -1 because I'm using my x values, guys. So notice I already labeled the points. So I have that information for me. I just have to look and say, okay, between which two x values, I already put them out there. I already wrote my coordinates. So it's decreasing between -3 and -1. All right, notice I don't use inequality equal signs because at -3, it's on that point. It's decreasing between the two values. Okay, constant between -1 and 2. Notice I'm using x's because I am talking about my x values. And then it's increasing from from +2 to, oh, hey, arrow, so positive infinity. All right, and behavior. As x is approaching positive infinity, that is the right side of my graph. Which way is my right arrow pointing? It's pointing up. Notice I have a positive infinity for the right and a positive infinity for the up. On the left side, I'm approaching negative infinity. Okay, the left side of my graph, I don't have an arrow. That's an endpoint. So I can't say it's approaching anything. So for right now, we're just going to put NA. There is no arrow. You can only have two answers here if I have two arrows. Okay, just looking for the arrows. That is my graph. Let's take a look at one more example. Okay, this is actually called a cubic. It's an x to the third, which we will take I'll look at more closely a little bit later on in the year on how to graph this and all this good stuff. But here's my cubic function, y equals x to the third. So let's go ahead and label. I'm going to start by labeling my infinities. Positive, negative, negative, positive. Turn points. So this one's at -3, 1, 2, 3, 4, 5. I don't have to label my intercepts on here. I can if I want to, but they're not gonna help me with my increasing and decreasing. They're just gonna tell me about where it's crossing x and y. Turning there, and it's turning down here. It looks like, so it's not exactly on the point, so we'll say 1.8 and -4. If you're a smidge different, that's fine. I get it. But if you know it's technically not on x equals negative or +2. All right. Domain, 2 arrows. What did I tell you about domains with 2 arrows? Always all reals. And if you notice, it is going on forever and ever in both directions. I've got an arrow here. So as it's going up to positive infinity, it's also going right to positive infinity. Over here, I've got it going in both directions also. So my domain is all reals. And what do you notice about the range? Because the 2 arrows are pointing in opposite directions, that's also going to be all reals. There is no lowest value. There is no minimum or maximum. The arrows are going both up and down also. So I have all reals. All right, intercepts. It's crossing x at 3 places at -4, -1, and +3. So x equals -4, x equals -1, and x equals +3. Okay, so I can write those as points. Oops, wrote them out of order. That's okay. All right, where is it crossing y? It's crossing right here. All right, so it looks like it's at -2 1/4 or -2 1/3. Now remember, before I did tell you that you could plug in, we'll say -2.25. You could plug in 0 for x and solve, but we don't know the actual equation for this. This is an x cubed, but it's not the parent function. All right, we'll take a look at what the parent function looks like later. So there is some other stuff in our equation. So since we don't know it, we can't. So just guesstimate. It's fine. If you put -2 1/3, it's okay, guys, or -2 1/2. As long as you know you're between -2 and 3 and close to the -2, that's fine. Okay. All right, increasing, decreasing, the new stuff. So just trace it. Start from the left. It doesn't matter which way the arrow is pointing. Always start at the left side of the graph. So from here, I'm actually going up first. And I'm changing directions at my -3. I'm going to keep that in mind. And I'm turning, and I'm now going down. And then I change directions at my 1.8. And then I go up again. So I have 2 different up arrows. So I have 2 separate increasing chunks. So I'm just going to write them as literally 2 separate chunks. So it's increasing from -infinity, because remember, use your x value, -infinity to -3. And since I already have them labeled, I can just go ahead and write them. So increasing -infinity to -3. And then just put a comma and you can write your second one. Okay. I like to just go in order of the graph. So I'm going to do my decreasing now. It's decreasing from -3 to 1.8. That's telling me that between the x values of -3 and 1.8, my graph is decreasing. The y's are getting smaller. It's increasing again from the 1.8 to positive infinity. All right, I don't have any constants. Okay, end behavior, look at your arrows. As x approaches infinity, that's the right side of my graph, my right arrow. Which direction is it pointing? Up. So that's a positive infinity. Excuse me. X is approaching -infinity is the left side. Which way is my arrow pointing? Down to -infinity. Okay, so end behavior, guys, literally just look at your arrows pointing up or down. Increasing and decreasing, identify the coordinates of the turning point and use that to help you figure out between which 2 sections it's happening. All right, so I'm going to end the video here. There is more examples in here. They're for you to practice. Okay, there are answer keys. So as you're going through, you can check out things on the answer keys to kind of help guide you. If you have questions, please tweet me. Just one thing I want you to be careful of as you're going through here, taking a look at number 1, there is a square root. You can do that, okay? Think about restrictions on domain and range. Think about that endpoint and the fact that there's only 1 arrow. All right, work together and help answer each other's questions. And check out the answer key if you get stuck to try to help you.